What I'm going to talk to you about today is volcanic lightning, what it is, how it is made, and times where it has been seen around the world. So, to explain a little bit about why I was interested in this topic is that while I was searching about natural disasters and things that our Earth was capable of, I started to think about what would happen if two disasters would have collided. Then I started to research about natural disasters like tornadoes and tsunamis until I saw a picture of volcanic lightning. The sight of these two disasters struck my interest, and I got very curious to see how this would occur and if it has actually happened on our planet in the past. I believe people should be interested in this topic just to see the beauty and impressive things the Earth and our planet is capable of. To get started, I'm going to give you some background on lightning and what exactly causes it to occur. First, air rises to form water vapor, which later starts the beginning of the formation of a cloud. Once this happens, the process keeps reoccurring until it forms a much bigger and bigger cloud. After this, it becomes very cold at the top of the cloud, which then causes the water vapor to turn into ice. Eventually, the ice particles start to move around and begin to collide with each other, creating electrical charges within the cloud. The positive charges would be on the top and the negative charges would sink to the bottom. Once the charge grows large enough, a jolt of lightning is created within the cloud. One fact that I didn't know about lightning that I found was that most of the lightning it's created is often contained within the cloud itself. The only way that lightning is shot down at us is when the negative charges at the bottom of the cloud are attracted to positive charges found on the surface of the Earth. Now for some background on volcanoes. There are three main reasons to why volcanoes erupt: the buoyancy of the magma, the pressure from the gases in the magma, and the injection of new batch of magma into an already existing and filled magma chamber. The buoyancy of the magma causes the eruption of the volcano, since the melting rock from the earth is continuously adding more magma, causing the lighter magma to rise to the top. If the density of the magma between the zone of its generation and the surface is less than that of the surrounding and overlying rocks, then the magma pushes itself to the surface and erupts. The second way a volcano erupts is of course the gases contained within the magma itself. The gases within magma contain andesitic and rhyolitic compositions, which also contain dissolved volatiles such as water, sulfur dioxide, and carbon dioxide. These dissolved gases in magma at atmospheric pressure is zero, but rises with increasing pressure, causing the volcano to eventually erupt. Lastly, the injection of new magma. This new magma makes its way into a chamber that is already filled with magma of similar or different composition, which causes some of the magma already in that chamber to move up in the conduit and erupt at the surface. Now that we know a little bit about each natural disaster, we can continue into learning what exactly makes volcanic lightning. Volcanic lightning is the collision between two natural disasters, lightning and volcanic eruption. So far, there are two theories to why this occurs. One theory is based on static electricity. This process is caused from the particles in dense ash clouds rubbing together near the ground. The other theory is based off of the formation of ice in the top of a thinning ash cloud. One study that goes along with the first theory is the Sakurajima volcano in Japan. For that study, the scientists recorded a video of volcanic lightning at Sakurajima, which happens to be one of the world's most active volcanoes. By comparing the video to infrasound and electromagnetic data, the researchers were able to discover thick clouds of ash giving rise to static electricity. Because of the static electricity, the particles within the ash clouds rubbed together and the resulting charge buildup generated the lightning strikes within the volcano. As a matter of fact, the picture you see here is actually one of the pictures taken of Sakurajima during the collision of lightning and volcanic eruption. The second study that goes with the other theory is the Calbuco volcano in Chile. During this study, researchers devoted their time by tracking the location of the lightning strikes. They began to find out that the bolts of lightning were breaking about 60 miles from the eruption and at near stratospheric heights of about 12 miles above Earth's surface. What the scientists began to conclude was that ice had formed at the top of the thinning ash cloud, which was also carrying water vapor, producing lightning in a similar way to how thunderclouds are often created. And just like the slide before, the picture in the background is the picture capturing the moment of the lightning colliding with the eruption at the Calbuco volcano. So, to conclude, volcanic lightning is the collision of two natural events that can be caused by either static electricity in the ash clouds or the formation of ice on top of the ash clouds. Because of these two theories, volcanic lightning is furthermore explained and gives scientists more of an incentive to find more ways that could trigger this sort of reaction in a volcano.